Welcome to The Explainer. Today, we're really getting into the anatomy of a fire. We're going to look at what the experts say, from investigation reports and safety manuals to figure out how we can stop disasters before they even have a chance to start. All right, let's jump right in. When you boil it all down, fires really fall into two big buckets: the ones people start on purpose and the ones that just happen. And you'll see, they're completely different beasts. So, on one hand, you've got arson. We're talking malicious, right? Someone using something like gasoline to make sure the damage is fast and catastrophic. But then you have accidental fires. And honestly, these are way more common. They come from simple carelessness, or maybe a faulty wire. And here's the key thing: these are the ones we can actually do something about.
Yeah, and arson is almost never a random act. There's always a why behind it. It could be anything from a desperate business owner trying to cash in on an insurance policy, to an angry ex-employee looking for revenge, or even someone trying to cover their tracks after another crime. The stories behind these fires are pretty intense. Okay, so let's put arson aside for a minute and talk about those accidental fires. Where do they usually start? Well, there are a few usual suspects that pop up again and again.
Believe it or not, a huge number of fires start right inside our walls. You've got old, maybe frayed wiring, or outlets that are just completely overloaded with all our gadgets. That's a recipe for overheating. And this is a really big deal in older homes, because their electrical systems just weren't built for the kind of power we use today.
And then, of course, you have the kitchen and living room. Absolute hot spots for fires. I mean, think about it. How easy is it to walk away from a pot of oil on the stove for just a minute? That can turn into a massive grease fire in no time. Or in the winter, that little space heater you push just a bit too close to the couch? That's basically a ticking time bomb.
And here's a classic, and sadly, a really deadly one: the cigarette that wasn't put out all the way. That little ember gets tossed in a trash can, or it falls between the couch cushions, and it can just sit there, smoldering for hours. It slowly builds up heat until, bam, you've got a full-blown fire long after everyone's forgotten about it. And it's not just at home, right? What about at work? A lot of the time, it's the machinery we count on every single day. Motors that overheat, parts that create friction because they haven't been oiled, or even just a single stray spark from some maintenance work. These are the kinds of quiet, sneaky fire starters that you find in almost any industrial setting. Okay, so we've talked about what starts a fire: the spark, the heat source. But what decides if it's a small flame or a raging inferno? Well, that brings us to this really critical concept called fire load. So what is fire load? To put it simply, it's a measure of how much stuff in a room can actually burn. Just think of it like the total fuel available in a space. The more flammable things you have packed in, wood, paper, plastics, whatever, the higher your fire load is. And this table here just lays it out perfectly. You've got an empty concrete room, basically zero fire load, right? Nothing to burn. Then you have a standard office. Desks, paper, computers, that's a medium fire load. But then look at the chemical warehouse, filled with solvents and paints. That is an incredibly high and frankly terrifyingly dangerous fire load. So, we've been talking about the fuel in a room, the furniture, the boxes. But what happens when the fuel becomes the room itself? When the actual air around you becomes the danger? That's when we get into the wild world of explosive atmospheres. I mean, seriously, what if the air itself could just explode? That's the huge question that led to what are known as the ATEX directives. These are a set of European safety rules, and they're all about managing situations where flammable gases, vapors, or even superfine dust, like in a grain silo or a paint booth, mixed with the air in just the right, or I guess the wrong way. So, ATEX breaks these danger areas down into what they call zones, and it's all based on risk. You've got Zone 0, which is the absolute most dangerous. Think about the space inside a fuel tank, where that explosive mix is pretty much always there. Then there's Zone 1, where it's likely to happen during normal work. And finally, Zone 2, which is the least risky. An explosive atmosphere there is pretty unlikely, and if it happens, it's not going to last long, maybe from a small leak. So as you can imagine, working in any of these zones requires insane levels of caution. One tiny spark could be catastrophic. We're talking about using special X-proof equipment that's built specifically not to create a spark. Literally every potential ignition source, your cell phone, a regular tool, even the static electricity on your clothes, has to be controlled like your life depends on it, because it does. All right, so understanding the danger is the first half of the battle. Now let's talk about the toolkit. What can we actually do to stop these fires from ever getting started? Let's get into some real, actionable strategies. Okay, let's talk about hot work, stuff like welding or grinding. A hot work permit is so much more than just a piece of paper. It is a life-saving checklist. First, you inspect a whole 10-meter circle around the work area for anything flammable. Then you either move that stuff out or you cover it with fire-resistant blankets. You also need a fire watch, a dedicated person whose only job is to watch for sparks. And here's the most important part. That person has to stick around for up to an hour after the work is done, just hunting for any tiny hidden embers that could flare up later. And when you're dealing with flammable liquids, there's this fantastic little acronym to keep in your back pocket, VICS. It's a super simple but powerful checklist. V is for ventilation, to get those dangerous fumes out. I is for ignition control, no sparks, period. C is for containment, so no spills. E is for exchange. If you can swap it for something less flammable, do it. And S is for separation. Keep it far away from heat. It's really the whole package for handling this stuff safely. You know, all of this really boils down to one crucial point. And this quote says it all. In fire safety, the most important tool is vigilance. The fire you prevent is the one you don't have to fight. Look, all the rules and all the fancy equipment are important for sure, but they mean nothing without a culture of safety, without people being aware. Prevention isn't just a checklist, it's a mindset.
And that brings us to the end of this explainer. So I'll leave you with this question. Just take a look around you right now, your office, your workshop, even your kitchen. After everything we've talked about, what's one hidden fire risk you see? What's one small thing you can do today to lower the fire load or get rid of a potential spark?